Hey folks, welcome back. In this lesson, we're going to talk about DynamoDB Accelerator, otherwise known as DAX. So in the DevOps doctrine, let's click on In-Memory Acceleration, otherwise known as DAX. Now, DynamoDB is already designed for scale and performance. In most cases, DynamoDB response times can be measured in single-digit milliseconds. But what if you have use cases that require response times in microseconds? Well, for those use cases, you can use DynamoDB Accelerator. I'll refer to it in the rest of this lesson as DAX. DAX delivers fast response times for accessing eventually consistent data. And it's basically a DynamoDB compatible caching service, and it enables you to benefit from fast in-memory performance for these demanding applications that require microsecond response times. So DAX addresses three core scenarios. As in-memory cache, DAX reduces the response times of eventually consistent read workloads by an order of magnitude, again, from milliseconds to microseconds. Secondly, DAX reduces operational and application complexity by providing a managed service that is API compatible with DynamoDB. So it requires just minimal functional changes to use with an existing application. And thirdly, for read-heavy or bursty workloads, DAX can provide increased throughput and potential operational cost savings because it reduces the need to over-provision read capacity units. Now, what are some use cases for DAX? Well, it's ideal for applications that require the fastest possible response times for reads, such as real-time bidding, social gaming, and trading applications. So that fast in-memory read performance is ideal for these use cases. It's also good for applications that read a small number of items more frequently than others. Think about an e-commerce system that has a one-day sale on a popular product. So in this case, you could offload the read activity to a DAX cache until the one-day sale is over. Another use case, applications that are read-intensive but also cost-sensitive. And again, this has to do with your DynamoDB reads per second, your provision throughput. So if you instead use DAX, you can reduce the amount of read capacity units you'd need to purchase. And finally, another use case, applications that require repeated reads against a large set of data. An example would be a long-running analysis of regional weather data. In this case, the analysis could temporarily consume all of the read capacity in a DynamoDB table. But again, you could offload this to DAX, and the analysis could be performed against cached data. So that's a look at DAX conceptually. Now let's go to the management console and just set up a DAX cluster. And to be clear, a DAX cluster is made up of these nodes, these memory nodes, and you can configure the number of these nodes in the cluster, as we'll see momentarily. I'll quickly talk about what we're working with. I have a table in DynamoDB, and it's a pretty basic table. It has a partition key, doesn't have a sort key, just a pretty standard table. But if we feel the need, we can set up DAX for this table. So what we would do is go over to DAX, and the first thing we would want to do is create a subnet group. Now, it's really what it sounds like. The subnet group is a collection of subnets in your VPC. So DAX is designed to run within a VPC, and when you deploy DAX, your DAX cluster, so we're talking about the nodes within that cluster, will be deployed to the subnets within that subnet group. So we would go into subnet groups, and I've already done this, but we can step through this. We'd create subnet group, and we choose a VPC, and you'll want to have a VPC with more than one subnet. And then we can just select the subnets that we want our DAX cluster nodes to be deployed in. And then we can just click Save. Having supplied that information, we can then go ahead and create our cluster. Again, I've done this already, but we can step through this. The creation of this cluster takes 10 to 15 minutes. So let's just step through it, and we specify the node type. Determines the maximum amount of memory for a DAX cluster. And let's just go small here. It's just a demo. And that is the smallest we have. Let's do 3 nodes. We can encrypt this, but we won't. Now, we need a service role, and there is a service role for DAX. There's our subnet group. Now we have 2 subnet groups, so we would have a choice here. And then a security group. And then we would just launch the cluster. Now again, this takes 10 to 12 minutes, so I'll just move forward with the one I previously created, which has, other than the name of it, the exact same specs. Now, the last thing we need to do is configure the security group inbound rules. So our DAX cluster uses TCP port 8111, 8111 for communication. So we need to set up inbound traffic on that port. And this allows EC2 instances in our VPC to access our DAX cluster. And that's all we need to do. So I'll open another tab. Let's go over to EC2. Let's go into security groups. So there it is. Let's go to actions, edit inbound rules. Remember, our protocol is TCP. And remember, for custom TCP, we can manually enter our port number. And we'll just select our security group and click Save. So that's really all there is to it. Now, our second cluster is still creating, but remember, we were working with this first cluster. And again, they really have the same specifications, just other than the name. So again, DynamoDB is designed for scale and performance out of the box. It's going to give you millisecond response times, single-digit millisecond. But use cases may arise where you need microsecond response times. And that's where DAX comes in. You can configure a DAX cluster like we just did, and it's going to benefit you greatly for those types of use cases we have talked about in the DevOps doctrine. So thank you for joining me in this lesson. Let's move on to the next.